students. Today we will be discussing a new topic in our classes on mathematical tools and physics. Today we will discuss about functions and limits. Now, before I discuss about functions, there are certain terms related to it. Now, do you remember what is quantity? Quantity is anything that can be measured, constant and variable. A quantity whose value does not change during mathematical operations is called a constant. Like for example, pi, exponential, e, fractions. On the other hand, a quantity which can take up different values during mathematical operations is called a variable. We can use different alphabets, different symbols for denoting variables. Lastly, independent and dependent variable. Now this is something that you might have come across while dealing with graphs. If you remember, we always plot the independent quantity on the x-axis and the dependent quantity on the y-axis. So a variable quantity which can have any value within the specified limits is called an independent variable, whereas a variable quantity whose value depends upon the numerical value assigned to the independent variable is called as dependent variable. Like for example, distance and time. If you are asked to measure the value of distance traveled with respect to time, then time will be considered an independent quantity, the independent variable, and distance will be considered the dependent variable, because you are measuring distance with respect to time. So once we have understood what is quantity, what is constant, variable, independent and dependent variable, now we can understand what is function. If the value of a variable quantity y depends upon the value of some other variable quantity x through some relation, such that there exists only one finite value of y for each value of x, then y is called a function of x. So mathematically we represent y is equal to fx. F stands for function. So y is a function of x. This means as x changes, so does y. So obviously in this case x is what type of a variable? It is the independent variable. And what type of variable is y? Y is the dependent variable because it is dependent on the value of x. As x changes, so does y. For example, we considered an expression for y. Y is equal to 2x square plus 3x plus 4. So you can see that we have written down an expression for y. As x will change, so will y. Now if we put x equal to 0, so what should be the value for y? Y will become 2 into 0 square plus 3 into 0 plus 4. So obviously this will become how much? 4. Similarly, for x equal to 2, y will be equal to 2 square, 2 into 2 square plus 3 into 2 plus 4. So 2 square is 4, 4 2s are 8, 8 plus 3 into 2 is 6, 8 plus 6 14, 14 plus 4 is 18. So you can see as the value of x is changing, so is the value of y. So in this case, y is a function of x, and the function is written as 2x square plus 3x plus 4. So there are different types of functions. Like for example, if y is equal to x to the power n, we call it as a power function, where n is a constant real number. For n equal to 0, y will be equal to 1. Similarly, we can have a function like y equal to cos of x, or say sine of x. So in this case, the function will be called a trigonometric function. Like for example, you can have y equal to cos x into cot x plus cos square x. So this is also a trigonometric function. You can have an exponential function like y equal to a to the power x, where a is the positive number called the base number. And then you can have a logarithmic function like y equal to log of x square. In this case, the base will be e. Now hope you remember what does base e stand for. Obviously it stands for the natural log, or what is called the Neperian log. So in this manner we can have different types of elementary functions. Now we will discuss something new. This is limit of a function. You all have studied about different types of functions in your junior classes in mathematics, but limit of a function is something that you will be studying for the first time. Now, even though this topic is extremely important when it comes to dealing with calculus, and it will be covered in very much detail when this topic is taught in mathematics, but for the time being we will just have an elementary understanding of this topic. Whatever understanding is important in order to study the remaining topics in calculus, that is differentiation, precisely differentiation. So very quickly we will understand what is limit of a function, and then I will give you some examples. A function fx is said to tend to a limit L as its variable x approaches a constant a, such that the absolute difference between fx and L as x tends to a is negligible but not 0. Now, as I have read the definition for limit, you may find it difficult to have a clear understanding as what this definition actually implies to. So I think it will be easy for you once you go through one example, and then we can come back to this definition. So let me give you one example. For this I will be considering a function again. So y is equal to a function of x, and the function is written as x cube minus 8 divided by x minus 2. Now one basic rule in mathematics that you all might be knowing is that division by 0 is not allowed. So can anybody tell me when this function will assume an indeterminate value? That is, it cannot be defined. Indeterminate means when the function becomes 0 by 0. Obviously for x equal to 2. When x becomes equal to 2, then the denominator will become 2 minus 2. For example, I am just doing it. If x is equal to 2, then y will be equal to 2 cube minus 8 divided by 2 minus 2, and this will become 0 by 0. Now 0 by 0 is indeterminate, that is, it cannot be defined. So we can say that this function can be defined at all points except x equal to 2, isn't it? So I can write down that this function can be defined at all points except x equal to 2, because if we use x equal to 2, as you can see that it has assumed this x form 0 by 0. So for all values of x very close to 2, that is more or less than 2, the function tends to a certain value. What value it is? Let us calculate. Like for instance, if x is equal to a value that is slightly less than 2, let us take x equal to 1.98. So what should be fx? Fx should be 1.98 whole cube minus 8 divided by 1.98 minus 2. So on solving this fraction, you will get fx equal to 11.88. Okay. Similarly, if I put x equal to 1.99, then fx will be 1.99 whole cube minus 8 by 1.99 minus 2, it will become 11.94. Earlier it was 11.88, now it is 11.94. In a similar manner, let us last of all take a value which is slightly more than 2. Let us see what value the function assumes. So it will become equal to 12.06. So going by these three examples, when x is slightly less than 2 and when it was slightly more than 2, you find that the value of the function remains very close to 12. So we can write down from all values of x very close to 2 but not exactly equal to 2. Now you might have seen that I have never took x exactly equal to 2, because if x is equal to 2, it will become 0 by 0. So we need to consider the values of x less than 2 or slightly more than 2. So for all values of x very close to 2 but not exactly equal to 2, I can write down x cube by 8 divided by x minus 2 to be approximately equal to 12, isn't it? So this is how we define limit. We can write down limit. In short, it is written LT, or in some books you will find it is written LIM. So limit x. Now how do we read this? We read it as x tending to 2 or x approaching 2. X is not equal to 2, it is approaching 2. So x tends to 2, x cube minus 8 divided by x minus 2 equal to 12. So this is how we define limit. So now we can go back to the definition of limit. A function fx is said to tend to a limit L. So the function that I had took, what was the function? It was x cube minus 8 divided by x minus 2 is said to tend to a limit L. What was the limit? 12. As its variable x approaches a constant a. What was the constant? 2. Such that the absolute difference between fx and L as x tends to is negligible but not 0. Obviously, once we have calculated it, the value of the function as x tends to 2 is negligible but not 0. It should not be equal to 0. So this is the way we define limit of a function. Now there are certain important limits in physics that you need to remember. You will be studying many calculations when this topic is covered in mathematics, but some important limits used in physics I would like to tell you that you need to remember. First, limit theta tending to 0. Sin theta is equal to theta. Now here theta is in radians. Next, limit theta tending to 0, sin theta by theta is equal to 1. Third, limit theta tending to 0, cos theta is equal to 1. Next, limit theta tending to 0, tan theta is equal to theta. Again, theta is in radians. Now In the same expression, I will do one thing. Limit theta tending to 0 if tan theta divided by theta, okay, if tan theta is divided by theta, then the expression will become equal to 1. Like, this is the modified thing that I am going to write down. Tan theta by theta is equal to 1. Last of all, limit of x plus 1 by x to the power x, where x is tending to 0, is equal to limit of 1 plus, let me write it down separately, okay, that is equal to e, and the value of e is 2.718. Okay, so these are few important limits in physics that you need to remember. Let us very quickly solve one question based on limits. Like, for instance, the question given to you, you are asked to solve this question. How you are going to solve it? Let me tell you the solution. So I will be writing down the question once again. And then in the next step I will be doing one modification. And then overall divided by h. Now can you understand what modification I have made? I have added a plus h whole square sine a and then subtracted a plus h whole square sine a. See, in the first term I have written the subtracted term a plus h whole square sine a, and the next term it has been added. So overall the expression remains unchanged. Now the utility of doing this is that the expression changes into a trigonometric function, a trigonometric identity, and it will become convenient for us to write down the result. That's exactly what we'll be doing next. So limit h tending to 0, 1 by h a plus h whole square. Now the first term was sine a plus h minus sine a. This is in the form sine a minus sine b. So sine a minus sine b is cos of a plus b by 2 sine of a minus b by 2. So on solving you will get 2 cos a plus h by 2 and then multiplied by sine of h by 2. This will be the first term plus the second term, limit tending to 0, 1 by h sine of a. See, in the brackets we are having a plus h whole square minus a square. So I will simply write down the expansion, a plus h whole square. So a square plus 2ah plus h square minus a square. Let's solve it out. This will be cos of a plus h by 2 into sine of h by 2 by h by 2. See, in the first case we are having 1 by h, so instead of writing h I have written h by 2, and then in the numerator also I made h by 2. That 2 has been brought down, this 2, okay, plus limit h tending to 0 sine of a and into so in this case we can see we can remove a square and then dividing by h. So dividing by h you are left with 2a plus h. So that's what I have written. Now we have to substitute the limit. You have to remember that sine theta by theta, limit theta tending to 0, sine theta by theta is equal to 1. So obviously this particular term will become equal to 1, and then you can put h equal to 0. So on putting h equal to 0 you will get now you can take out a as common. So in this manner we can solve the limit. Now using a similar method, try to solve this question. You will solve this question. Okay, so we will discuss about differentiation in our next class.